Hi, I am Neelakandan, TPGAT from Vellore. In this video, we are learning probability and random process in this subject. First of all, Unit 1, one-dimensional random variable. A random variable definition is a random variable capital X is real valued function from S to R. That is, X is random variable. Thus, random variable S means sample space and it tends to R. R means real numbers, real valued function, that is real numbers. So, the sample space to real numbers that maps is capital X, that is a random variable. A random variable is a function that converts each event into a number. That is, the example, let X denote the number of heads obtained when tossing 2 coins simultaneously. Then the sample space is X is equal to HH, tail, 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 head, tail, sorry, head, 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 tail, tail, head, tail, tail. So here X denoted is number of head. So here head, head, this is 2 head here. So this event is mapping to this real number 2. Next one is this term, head, tail. Here is only one head. Here is only one head. So these two terms, two events map to 1. And tail, tail. Here is not contained head. So this is mapped to 0. That is random variable. The types of random variable is, there are 2 types of random variables. One is discrete random variable. Another one is continuous random variable. The discrete random variable is a discrete random variable whose set of possible values is either finite or countably infinite. This is called discrete random variable. The finite values, this one is finite value. Capital X is equal to 0, 1, 2, 3 up to 6. This is finite value. Or countably infinite means X is equal to 1, 2, 3 up to infinity. That is countably infinite. The discrete model is, the random variable is given, the X values is 0, 1, 2, next values are given in X. That is discrete model. The continuous random variable is a random variable, capital X is said to be continuous if it takes all possible values between certain limits, say from real number A to B. That is, the X values are given in interval form, A comma B, 1 to 5, 1 comma 3, half closed interval. This one is half open interval, etc. The continuous random variable given in X values in the form, interval form. That is continuous random variable. The discrete random variable using summation symbol. The continuous random variable is solving using integral symbol. Very important concept. Next, to find moment generating function, MGF. That is discrete model. In this discrete model, the MGF is mx of t equal to expectation of e power tx. Mx of t means that is moment generating function, that is denoted by exponential form e of expectation form, that is e of e power tx equal to, using summation symbol for discrete. Summation x is equal to xi e power tx p into capital X is equal to x. The continuous model, mx of t equal to e power tx is equal to, using integral form for continuous, e power tx into f of x into dx. Note, when moment generating function are given or obtained when use following formula for mean and variance. Mean. E of x is equal to d by dt into the mx of t at t equal to 0 equal to mean. This formula using only in homogeneity function given or obtained. You want find mean and variance using this formula. E of x is equal to d by dt into mx of t at t equal to 0 equal to mean. Second one, the E of x square is equal to d square divided by dt square into mx of t at t equal to 0. Third one is variance formula equal to E of x square minus E of x whole square. The standard distributions are first distribution, binomial distribution, Poisson distribution. Third one is geometric distribution. These three distributions is based on discrete type. Fourth one, uniform distribution, exponential distribution, normal distribution. These three distributions are continuous type. The first one is binomial distribution. A discrete random variable x is said to be follows a binomial distribution if its probability mass function is given by the p of x is equal to ncx p power x into q power n minus x, x is equal to 0, 0, 1 to up to n. The finite values contain finite values in binomial distribution. The x values are only finite values are contained in binomial distribution. Very important. So the probability mass function p of x is equal to ncx p power x q power n minus x. That is the probability mass function of binomial distribution, where n is number of trial, x is number of success, p means probability of success in single trial, q means probability of failure in single trial, and p plus q, that is total probability, probability of success plus probability of failure, that is total probability, equal to 1, that is total probability. Formula, that is basic formula, a plus b the whole power n equal to the a power n plus nc1 a power n minus 1 into b plus nc2 a power n minus 2 into b square plus etc. plus b power n. Now, very important, find the homogeneity function for binomial distribution and hence find its mean and variance. The same as the 6 distributions are, you want to find MGF and mean and variance. Very important. Any one distributions asked in online university examinations. This binomial distribution is very important. Now find MGF. Formula is mx of t equal to e power tx is equal to summation. Because of the binomial distribution is a discrete model, so summation using x is equal to 0 to n e power tx into p into x is equal to x. The probability mass function of binomial distribution is the e power tx into ncx p power x into q power n minus x. This e power tx is contained in the expectation of e power tx. This e power tx is here written as e power tx into p of x is equal to x. Now here e power tx, here is power x, here is also power x. So this term can be written as rewrite form x is equal to 0 to n ncx into p into e power t the whole power x into q power n minus x. Now apply x is equal to 0 in this term, we get nc0. nc0 values are 1 and p into e power t the whole power 0, that values are also 1. So only we contain q power n only. So plus next you want to apply x is equal to 1 nc1 q power n minus 1 p into e power t plus want to apply x is equal to 2 nc2 q power n minus 2 p into e power t the whole square plus etc. plus want to apply x is equal to n, so nc values ncn that value is equal to 1 and p into e power t the whole power n, here q power 0 that values are 1. So to contain this term, we get this term, this form is a plus b whole power n form, so it can be written as this q plus p e power t the whole power n, that is mgf, that is mx of t is equal to q plus p into e power t whole power n, that is homogeneity function for binomial distribution. Next, to find mean, that is e of x. E of x equal to d by dt into mx of t at t equal to 0. Now the homogeneity function mx of t values are substituted in this term, we get d by dt into q plus p e power t the whole power n at t equal to 0. Next, you want to differentiate this term, we get n q plus p e power t the whole power n minus 1. After differentiate inside of the bracket, we get p into e power t at t equal to 0. Now put t equal to 0 in this term, put t equal to 0 in this term, we get n into p plus q the whole power n minus 1. Here e power 0 values are 1, so p. Here is also e power 0 values are 1, so p. Since e power 0 equal to 1, p plus q equal to 1, that is total probability. So e of x is equal to np equal to mean, that is mean value. To find e of x, the whole e of x square, second moment. Formula is e of x square is equal to d square divided by dt square into mx of t at t equal to 0. Now substitute this mx of t values, you get t square divided by dt square q plus p into e power t the whole power n at t equal to 0. Now differentiate, one time differentiate, we get n into q plus p e power t the whole power n minus 1 into p into e power t, that is previous term in e of x. Now we want to take this n into p, that is constant, take this outside, can be written as np into d by dt into q plus p e power t the whole power n minus 1 into e power t at t equal to 0. Here e power 0 value is 1 and p plus q equal to 1. Now using this formula, differentiation of uv formula, you get equal to u dv plus vd. Here this is t function, this is also t function, these two functions are in multiple, so we want using this basic formula, differentiation of uv equal to u dv plus v du. This formula, this is you want to take it this u, this is you want to take it this v, so np into u is fixed, so q plus p into e power t into n minus 1 into e power t plus e power t is fixed, that is the differentiation of e power t is e power t plus, now e power t v is fixed, e power t is fixed, then differentiate of u, that is differentiation of this term, we get n minus 1 into q plus p into e power t the whole power n minus 2. Next you want differentiate of inside of the bracket, we get p into e power t at t equal to 0. Now equal to np into n minus 1 into q plus p n minus 2 into p plus q plus p whole power n minus 1, that is e power 0 equal to 1 and p plus q equal to 1. So These values are 1 and these values are 1. So next step we will get np into p into this p into n minus 1 plus 1, np into multiply this term we get np minus p plus 1. Now multiply this np inside of the bracket, we get the np the whole square minus np square plus np. This step can be written as np the whole square plus, take this outside, np. So np into 1 minus p. 1 minus p values are q. So the e of x square equal to np the whole square plus npq. That is e of x square value. Next, to find variance of x. The formula, variance of formula is equal to e of x square minus the e of x the whole square equal to the np the whole square plus npq minus the e of x values are np. So the np the whole square. Now np the whole square minus np the whole square cancel. Now we get the answer npq. That is the variance. Next, Poisson distribution. A discrete random variable x is said to follow a Poisson distribution if its probability mass function is given by p of x is equal to e power minus lambda, the lambda power x divided by x factorial. Here x values are 0, 1, 2, 3 up to infinite values. This x values are given in the model. The Poisson distribution is a discrete random variable, this discrete type. Second question, find the moment generating function for Poisson distribution and hence find its mean and variance. First of all, find mgf. The formula is mx of t equal to e of e power tx is equal to summation x is equal to 0 to infinity the e power tx into p of x is equal to 0. Now the probability mass function of Poisson distribution is e power minus lambda into lambda power x divided by x factorial. Here is lambda power x, here e power t the whole power x. So multiply this two term, we get e power minus lambda is constant, take this outside. E power minus lambda, take this outside. Summation 0 to infinity lambda into e power t the whole power x divided by x factorial. Next we want to apply these values one by one. We get the series e power minus lambda plus 1 plus lambda into e power t the whole power 1 divided by 1 factorial plus lambda into e power t the whole square divided by 2 factorial plus etc. This form is e power x form. So e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus etc. Here x is equal to lambda into e power t. So e power minus lambda into e power lambda t. Lambda into e power t. So base are equal, power is added, we get mx of t equal to e power lambda is taken this outside. So lambda e power lambda into e power t minus 1. That is moment generating function of Poisson distribution. Next we want find out this mean, that is e of x. The e of x formula is d by dt into mx of t at t equal to 0. Now substitute this mx of t values d by dt into e power lambda into e power t minus 1. This differentiation of this function is, that is since differentiation of e power lambda into e power t minus 1 equal to e power lambda into e power t minus 1 into lambda into e power t. So substitute this value. E power lambda into e power t minus 1 into lambda into e power t equal to 0. Next the e of x equal to lambda. Substitute t equal to 0 in this function. we get lambda, that is e power lambda into e power 0. E power 0 value is 1, so 1 minus 1 is the e power 0, so that values are 1, and the lambda into e power 0 values is 1, so the e of x is equal to lambda, equal to mean. Next we want to find out e of x square value. E of x square is equal to d square divided by dt square into mx of t at t equal to 0. Now substitute this function, we get d square divided by dt square into e power of lambda into e power t minus 1 at t equal to 0 equal to d by dt. Differentiation of this term in previous solution, e of x solution, that is e power lambda into e power t minus 1 into lambda into e power t. Next differentiation, you take this constant lambda outside. Next we get lambda is constant, take this outside. Now the e power lambda into there is t function, this is also t function, this two t functions in multiple, so we want using the basic formula differentiation of uv. Differentiation of uv equal to udv plus vdu. This formula we get lambda into, this is u fixed, e power lambda into e power t minus 1. Differentiation of e power t is e power t plus e power t is fixed. Now differentiate this function, e power lambda into e power t minus 1 into lambda into e power t at t equal to 0. Now put t equal to 0 in this function, we get e power lambda into e power 0 values are 1, so 1 minus 1, this whole power e power 0, so that is value is 1, so e power 0 is 1, so this term is 1 plus these values are e power 0 1. Next this is e power 0 is 1 lambda into e power 0, that is values are 1, so lambda, so 1 plus lambda. Now multiply this lambda inside, we get e of x square equal to lambda plus lambda square. Next you want to find out this variance of x, that is the variance of x equal to the e of x square minus e of x the whole square. Now substitute this e of x square, lambda plus lambda square minus the lambda square. Lambda square are cancelled, we get variance of x equal to lambda. So Poisson distribution is over. Next, geometric distribution. A discrete random variable x is said to follow a geometric distribution if its probability mass function is given by, first one is the probability of x is equal to q power x minus 1 into p, where x is equal to 1, 2, 3. Here x is equal to 1, 2, 3, that the function is q power x minus 1 into p. Or another function of geometric distribution is p of x is equal to x q power x into p when x is equal to starting values are 0, so 0, 1, 2, 3 etc. Exercise, find the momentarity function for geometric distribution and hence find its mean and variance. Hint, take this probability function, one take this function, then the mx of t values are p divided by 1 minus q into e power t. Next e of x values are q by p, the e of x square equal to q by p plus 2q square divided by p square. Variance of x is equal to q by p square. Next, continuous type, that is uniform distribution, very important distribution. A continuous random variable capital X is said to follow a uniform distribution in a comma b, then the probability density function is given by, continuous type function is mentioned probability density function, discrete function is mentioned probability mass function. is given by f of x is equal to 1 divided by b minus a less than x less than b, otherwise function is 0. Which interval given here that function is changed, that is here is a comma b is interval, so 1 divided by b minus a less than x less than b, that is uniform distribution. Next, find the moment generating function for uniform distribution and hence find its mean and variance. Find MGF. Mx of t equal to expectation of e power tx is equal to integral. This is continuous type, so use integral over x e power tx into f of x into dx. Here integral a to b e power tx 1 divided by this f of x is 1 divided by b minus a, so b minus a into dx. 1 divided by b minus a is constant, so take this outside. We get 1 divided by b minus a into integral of interval is a to b e power tx into dx. Now the integration of e power tx is e power tx divided by t, limit is a to b. Now apply limit for x. Here take this outside, 1 divided by b minus a into t into the e power bt minus e power at. That is moment generating function of uniform distribution. Next, to find e of x, that is mean value. Using the formula e of x equal to the d by dt into the mx of t at t equal to 0. Now substitute this value mx of t in this, we get d by dt into 1 divided by b minus a into t into b e power bt minus e power at t equal to 0. Now the exponential series is expand, we get e power bt, that is expand, and minus e power at, that is expand, we get the series d by dt into 1 divided by b minus a into t into, that is e power bt exponential 1 plus bt divided by 1 factorial plus bt the whole square divided by 2 factorial plus bt the whole cube divided by 3 factorial plus etc. minus this is expansion of e power at, that is 1 plus at divided by 1 factorial plus at the whole square divided by 2 factorial plus at the whole cube divided by 3 factorial plus etc. at t equal to 0. Next step, this is plus 1, this is minus 1. Multiply this minus sign inside, is totally minus sign we get. So this is plus 1 and this is minus 1, cancel. Here minus sign or inside, minus sign multiply inside, this total series is negative sign. So plus 1 and minus 1 is cancelled. Next, this is plus term, this is minus term. So the next step is d by dt into 1 divided by b minus a into t into plus 1 minus 1 cancel. So b minus a into t divided by 1 factorial plus b square minus a square, b square minus a square into t square divided by 2 factorial plus b cube plus a cube minus a cube into t cube divided by 3 factorial plus etc. at t equal to 0. Now this term can be written as d by dt into 1 by b minus a into t, b minus a into t divided by 1 factorial plus b square minus a square can be written as b minus a into b plus a into t square divided by 2 factorial. Here b cube minus a cube can be written as b minus a into b square plus ba plus a square divided by 3 factorial into t cube plus etc. at t equal to 0. Now multiply this 1 divided by b minus a into t. Now cancelling there, this term is 1, that is d by dt into these two terms are cancelled, so 1 plus here b minus a into t is cancelled, therefore b plus a into t divided by 2 factorial plus here b minus a into t is cancelled, so b square plus ba plus a square into t square divided by 3 factorial plus etc. at t equal to 0, except b. Now differentiate, we get differentiate, this 1 is 0. Next this is t with respect to t, differentiate with respect to t, this is constant term, b plus a divided by 2 factorial is constant term, so differentiation of t is 1, so b plus a divided by 2 factorial plus this is constant term, so writing there the t differentiation of t square is 2t plus etc. containing t terms. The above terms are containing t terms. Now put t equal to 0, we get this term is 0, this term and above of this term is containing t term is also 0, so this is only constant term, so answer is the e of x equal to b plus a divided by 2, that is mean. Next we want to find out this e of x square. Formula is the d square divided by dt square into mx of t, so mx of t values are substituted here, 1 divided by b minus a into t into b e power dt minus e power at. This is expand in previous e of x previous term, we get cancelling the final answer d by dt, differentiation of this term expanded and differentiated one time, we get the previous solution, d by dt into b plus a divided by 2 factorial plus b square plus ba plus a square divided by 3 factorial into 2t plus etc. Now again differentiate with respect to t, we get this is constant term, so 0. Next b square plus ba plus a square divided by 3 factorial into differentiation of 2t is 2. Next this is contain of t term, because of this is a higher degree of t, so differentiate, we get containing t terms. So now put t equal to 0, we get the t terms are 0, so only we get the constant terms. Cancelling there, we get e of x square is equal to b square plus ba plus a square divided by 3. This is 3 factorials are 6, so cancelling with 3. Next, to find variance, formula is e of x square minus e of x whole square. The e of x square is this b square plus ba plus a square divided by 3 minus e of x values are b plus a divided by 2. So the whole square b plus a the whole square divided by 2 square is 4. Now this term is writing that b square plus ba plus a square divided by 3 minus expanded this b plus a the whole square, b square plus 2ba plus a square divided by 4. Now take this LCM, that is 12. 12 is common greatest multiple, so multiply this term in 4, multiply this in this term 3, so we get 4b square plus 4ba plus 4a square minus, multiply this minus sign inside, we get and multiply 3, we get 3b square minus 3 2s are 6ba minus 3a square divided by subtraction, we get b square minus 2ba plus a square. This is form is b minus a the whole square form divided by 12. Next is the exponential distribution. A continuous random variable x is said to follow a exponential distribution if its probability density function is given by the f of x is equal to lambda into e power minus lambda x, comma x greater than or equal to 0. that is probably density function of exponential distribution. Here x values are given in interval, so this is continuous type. Next, find the moment generating function for exponential distribution and hence find its mean and variance. First of all, you want to find out this MGF. Formula is mx of t equal to expectation of e power tx equal to integral over x e power tx f of x into dx equal to, now limit is here given exponential distribution 0 to infinity x e power tx into this function is lambda into e power minus lambda x into dx. So take this outside, lambda constant. So 0 to infinity e power, here is e power and e power, base are equal, power is adding that, base equal, so power is adding, that is here is minus lambda, here is t, x is common, take this outside, so you want to take this minus sign outside common, that is lambda into 0 to infinity e power minus of lambda minus t into x into dx. Now next step, integrating this term we get lambda into e power minus lambda t into x divided by the coefficient of x term, that is denominator, minus lambda minus t 0 to infinity limit. Now apply the limit, upper limit, we get e power minus infinity values are 0, e power minus infinity values are 0, so upper limit is apply, you get answer is 0. Next you want to apply lower limit, so minus apply x is equal to 0, that is e power 0 values are 1 divided by minus of lambda minus t. Now minus into minus plus, so mx of t equal to lambda divided by lambda minus t. To find e of x, mean formula is e of x is equal to d by dt into mx of t at t equal to 0. So the d by dt into mx of t values are lambda by lambda minus t at t equal to 0. So this term is can be written as in this form. Take this lambda is outside, so lambda into d by dt into lambda minus t the whole power minus 1 at t equal to 0. Now differentiate, we get lambda into the minus 1 is in multiple in front, that is differentiate lambda minus t the whole power minus 2 into, now differentiation of inside of bracket we get minus t, that is minus 1. So minus 1 into minus 1, that is plus. So this term is, next term is lambda divided by lambda minus t the whole square at t equal to 0. Now t equal to 0, we get lambda divided by lambda square. So cancel that, we get mean values are e of x is equal to 1 by lambda, that is mean. Next you want to find out e of x square value, that is formula d square divided by dt square, that is mx of t value lambda by lambda minus t at t equal to 0. Next, this term is can be written as lambda into d square divided by dt square lambda minus t the whole power minus 1 at t equal to 0. Next, lambda into d by dt, one time differentiated we get in the previous term, d by dt into lambda minus t the whole power minus 2 at t equal to 0. Next time differentiate, we get lambda into minus 2 into lambda minus t the whole power minus 3 into differentiation of inside bracket, that is minus 1. Differentiate, we get minus 1. So minus into minus plus, so 2 lambda divided by lambda minus t the whole cube at t equal to 0. Now 2t divided by, put t equal to 0, we get 2 lambda divided by lambda cube. Cancelling that, the e of x square is equal to 2 by lambda square. Next, to find variance, that is the variance of x is equal to e of x square minus e of x the whole square equal to 2 by lambda square minus 1 by lambda the whole square. So this is can be written as 2 by lambda square minus 1 by lambda square. Now taking this LCM, we get the variance of x equal to 1 divided by lambda square. So finish the exponential distribution. Thank you.